So let's start with the question. A greedy grid. A path in a grid is called greedy if it starts at the top left cell and moves only to the right or downward, always moving to its neighbor with the greater value, or either if the values are equal. The value of a path is the sum of values of the cells it visits, including the start and the end. Does there exist an n cross m grid of negative integers such that no greedy path receives the maximum value among all down right paths? Okay, so basically in this question we are given that we are given the values of n and m, and we have to tell if there exists a path where if we go in a way such that we only move in the grid either in the right direction or in the downward direction, and we choose the path greedily, right? We have to get the maximum sum and we have to move in the direction where it is most greater element, right? So we have to tell that if we follow this greedy strategy, does there exist any array, 2D array, that does not give us the optimal answer. Okay, so let's understand it with the first test case where n is 3 and m is also 3. So here is this grid which is 3 cross 3 grid which is given, right? And if we follow a greedy path like from 3, we will move on, we can move in this direction or in the downward direction, right? But it is optimal to move in this direction because we have to greedily choose the maximum sum. So first the sum was 3, now it has become 3 plus 5 which is 8, right? Now we move in this direction. Now we have to check if whether we can move right or down. So we can move in the either direction. So let's move here. Okay, now we can move either in this direction or in this direction. Okay, so we move in this direction. Our sum is updating, it was 1 and then it's plus 4, right? And now it can go right either or down it cannot go, so it can go here. Okay, so as we can see, the sum we are getting is 3 plus 5 8, 9 and 13. So we are getting the sum as 13. Now what is the optimal solution of this problem? Now if we would have taken this path 3, then we have gone to 2, 3 plus 2, then we have gone to 5 plus 5, then we have gone to 4, and then we have gone to 3. So it's plus 4 and plus 3. So if we add all this, we get 17 as the answer, right? But if we were moving greedily, it gave us the answer as 13, while the optimal answer is 17. So yes, there exists a 2D array in which the answer is not optimal. The answer is not the maximum answer. Okay, so we have to tell whether this condition exists or not, whether there is an array in which the greedy answer is not the optimal answer. Okay, so that's how in this test case we can tell by seeing this array that yes, a greedy path is not optimal. In this case we can get it, right? So let's see the next test case, which is 1 and 2. Okay, so n and m is 1 and 2. Okay, so the number of rows is 1 while the number of columns is 2. So this would be the array with 2 elements in it. Let's take any number. For suppose let's take 1 and 2 here. Okay, so we would be starting with the from the top left corner, right, and we can move either right or down. So here down is not there, so it's going to move right. Now we get the sum as 1 plus 2, and it has reached the end because it cannot go anywhere. So we get the sum as 3. This is the greedy sum, right, and the optimal sum would also be 3 in this case. So we cannot get any other possible numbers here. We cannot write any possible numbers that would differ from the greedy path, right, because there is only one path that we can follow, and that's this here and here, right. We can only go in this direction, right. So doesn't matter what number is here, we would always be able to confirm that the greedy sum would always be equal to the optimal sum. Okay, because there is only one direction in which we can go. Okay, now let's take an example of n and m with n being 2 and m being 1. Okay, so the array would look like this. Let's for suppose take 3 rows and 1 column. Okay, so let's write down any numbers 1, 2 and 3. So we can also see here that the only direction from the top left we can go is downwards direction. Okay, so there is only one path that is possible, which will be equal to the greedy path, which will be equal to the optimal path, right. So we can see that there are two cases in which it is possible. Either n is 1 or either m is 1, because the direction would be the same. Okay, now let's take another example, n and m as 2 and 2. So it's going to be a 2 cross 2 matrix, right. So if we write here numbers, any numbers 1, 2, 3 and 4 for suppose. Okay, so from the top left we can either go here or we can either go here. So the optimal or the greedy way would be to go here. Okay, and from here to here. Okay, so the sum would become 1 plus 3 4 plus 4 8. Okay, and there are only two ways in this matrix in which we can go. It's either here or here, right. So in any matrix, doesn't matter, any number is here. For suppose here is 8, here is 10, here is 1 and here is 2. So we would be starting from here, and the optimal, the greedy solution would be to jump to 10, and from 10 to jump to 2, and the optimal solution would also be this. Okay, so we can see that in this case, and in this case, the answer would be no, because the optimal and the greedy path would be same here, so the maximum sum would be same. But as we have seen in the matrix, in the 3 cross 3 matrix, there are many paths possible, right. So it will happen that the greedy path and the optimal path are not equal in matrices other than these value of n and m. Okay, so I hope you understood the approach how to solve this question. we only have three cases. First, where n is either 1, or if m is either 1, or if n or m, n and m is 2 and 2. In these cases only the answer would be no, and in every other case the answer would be yes. Okay, so let's see the code for this question. So we have here n and m. We enter the values of n and m. We check if n is equals to 1, or if m is equals to 1, or if n and m are both 2 and 2. We output no, else the answer would be yes. So I hope you understood the code and the approach to solve this problem. If you have any doubts, you can leave down in the comment section. Thank you.